everyone, and welcome to This Explainer. Today, we're tackling literally the ultimate mind-bending question of existence. I mean, it's a question that's kept philosophers awake since antiquity, and honestly, it continues to push modern astrophysicists to the absolute limits of human understanding. So, does the cosmos go on forever, or does it actually have an edge? And if it has an edge, what exactly is beyond it? On the flip side, if it is infinite, what does that actually mean for reality as we know it? To even begin to grasp the infinity of space, we first have to understand our own place within it. So, let me hook you right now with a strange but mathematically true statement. Relatively speaking, you are literally the center of the universe. I know, it sounds a little arrogant, but mathematically, in terms of pure scale, human beings sit right at the precise halfway point of reality. And this brilliantly illustrates that exact point. If you look at the microscopic level, you have the Corynebacterium, which naturally lives on your skin. It measures about 0.3 micrometers. That is roughly 7.7 million times smaller than you. Okay, now compare that to the planetary scale. Earth is about 12,700 kilometers in diameter. And guess what? That is roughly 7.7 million times larger than you. It's wild, but you are perfectly symmetrically balanced right between the microscopic realm of bacteria and the planetary scale of our home world. Okay, let's dive into this. First, we'll cover the scale of everything. Then, observable versus the unknown. Next up, the shape of space, followed by infinite copies of you. And finally, how the universe ends. Section 1, the scale of everything, from microbes to galaxies. Let's do some cosmic zooming to really ground our understanding of the universe's sheer size. Take a medium-sized city like Lisbon. It's about 6,000 times larger than you, and it's permeated by this really complex network of roads. But exactly 6,000 times smaller than you? Those are your small arteries, permeating your body in a strikingly similar network. Pushing this to the absolute extremes, the observable universe is roughly 10 to the power of 27 times larger than you. To put that completely massive number into perspective, that is enough space to fit 465,000 Milky Way galaxies side by side. Yet right in the center of that scale, there you are. Because squeezed down to 10 to the 27 times smaller than you is a single proton. The scale is just staggering, and it brings us right to the absolute limits of human perception. Section 2, observable versus the unknown, beyond the 13.8 billion year limit. So the crucial point is understanding this boundary of 93 billion light years. Now you might be wondering, wait a second, the Big Bang happened 13.8 billion years ago, so shouldn't the universe just be 27.6 billion light years across? Well, actually, because space itself has been constantly expanding, the regions of space where that ancient light originally came from have been carried much, much further away. Because of that stretching, the total width of everything we can physically see, our observable universe, is about 93 billion light years across. But remember, that's just an at-least figure. That is literally just our local visual horizon. And that brings us to this incredibly sobering thought from astrophysicist Joseph Silk. He points out that we simply don't know what lies beyond that 93 billion light-year visual boundary. Since light from beyond that edge hasn't had enough time to reach us since the Big Bang, the true universe could be a trillion light-years wide, or it could just simply go on forever. We just don't know. And as Silk points out, we may never know for sure. But if we can't see the edge, cosmologists do have another trick up their sleeves, looking at the universe's geometry to determine if it ever actually stops. Section 3. The shape of space, finding the edges of reality. Cosmologists and mathematicians use a few different models to try and conceptualize the universe. The standard model often assumes the universe is flat and infinite, extending endlessly in all directions. But it could also be spherical and finite, meaning if you traveled fast enough in a straight line, you'd eventually loop right back to your starting point. It could even be a torus, which is essentially a giant cosmic donut, or a Poincare dodecahedral space, which kind of wraps around itself like a mathematical soccer ball. As an explainer, I'm absolutely not taking sides here. Every single one of these models is mathematically rigorous and studied deeply by the experts. Now, what's really interesting about this slide is how it solves a major misconception. We constantly hear scientists say our universe is flat, which basically means two parallel laser beams shot into space will stay parallel forever. And most of us hear flat and automatically assume that means infinite, like an endlessly extending piece of paper. But as Joseph Silk and other physicists point out, you can take a flat sheet of paper, roll it into a cylinder, and then loop the ends together to make a torus shape. That shape is still mathematically flat, but it is entirely finite. It just loops back on itself. No edges required. This whole concept is the field of cosmic topology. Researchers are literally scanning the cosmic microwave background, which is the leftover heat from the Big Bang, looking for repeating patterns. If the universe does loop back on itself like that torus, light could take multiple paths to reach us. That means we might actually see the exact same galaxies in different parts of the sky, just at different ages. So far, we haven't found any of these loops, but the search absolutely continues. One completely fascinating alternative to the standard model that uses this geometry is HTUM, the Hypertorus Universe Model. Instead of a singular Big Bang that just expands endlessly, HTUM proposes that the universe is a four-dimensional toroidal structure. It's cyclical. In this model, time isn't a fundamental straight line. It's an emergent property of the universe folding back on itself. It elegantly attempts to solve the singularity problem. You know, that infinitely dense point of the Big Bang, by essentially stating the universe is just a timeless, self-contained loop. But what if it isn't a loop? What if it truly, literally is infinite? Prepare yourself because the implications here are absolutely mind-bending. Section 4. Infinite copies of you. The mind-bending math of eternal inflation. Let's move to and see how this builds a terrifyingly simple yet completely inescapable mathematical reality. Step 1. Take a cubic meter of space. There is only a finite number of ways quantum particles can be arranged inside that box. Step 2. If the universe is infinite, well, space goes on forever. Step 3. If you have a finite number of combinations, but an infinite amount of space to put them in, eventually the exact arrangements of particles absolutely must repeat. By pure statistical inevitability, an infinite universe guarantees duplicate realities. As cosmological pioneer André Linde notes in this fantastic quote, this theory of eternal inflation means there is an exact copy of you right now watching this exact explainer in a duplicate universe. Physicist Max Tegmark likens this to an endless paperclip factory. If the mechanism that created our universe is running infinitely, it just keeps churning out outputs. Eventually, it has to churn out the exact same paperclip, or in our case, the exact same observable universe over and over and over again. Now, you might be scratching your head thinking, wait, if the universe is already infinite, how can it be expanding? Expanding into what? Well, physicists often use the analogy of Hilbert's hotel to explain this. Imagine a hotel with infinite rooms, and every single room is completely full. If a new guest arrives, the manager just asks the guest in room 1 to move to room 2 to room 3, and so on infinitely. Boom, a room opens up. An infinite space doesn't actually need an outside edge to expand into. The distances between things inside it simply stretch. But whether it's infinite or finite, looped or flat, what is the ultimate fate of all this space? Section 5. How the universe ends. The ultimate fate of everything. So how does the universe actually end? Cosmologists largely debate two main eschatological theories, and it all hinges on dark energy. If dark energy, which is the mysterious force pushing the universe apart, eventually ebbs and weakens, gravity will ultimately win out. The universe will stop expanding and literally collapse back in on itself, ending in a big crunch, maybe 33 billion years from now. But on the flip side, if dark energy remains constant, the universe will just continue to expand, pulling galaxies so incredibly far apart that the stars eventually burn out, resulting in a lonely, freezing heat death. But hey, there is a silver lining in some of the theories we've discussed today, and that's the concept of cyclical rebirth. Bouncing cosmologies and models like the Hypertorus Universe model we talked about suggest that a big crunch isn't actually the absolute end. Instead, all that collapsing matter compresses into a timeless singularity, which then violently inflates all over again. Under these neutral cyclical paradigms, the Big Bang wasn't necessarily the absolute beginning, and a collapse is simply the trigger for the next cosmic cycle. Which leaves us with this final, deeply existential thought to ponder as we wrap up this explainer. If space is truly infinite, and time is truly eternal, spinning out endless copies of galaxies, planets, and people, which version of you is sitting there right now asking the question? Thank you so much for watching, and keep wondering.